This is Algebra Lesson 3-3, Solving Inequalities Using Multiplication and Division. Now let's take a look at a couple of inequalities here. If we were to look at this, we're going to use either the greater than or the less than symbol to answer. So 4 times 3, which would be 12, is that greater than or less than 3 times 1 times 3, which is 3? Well, 4 times 3 would be greater. If we multiplied 4 times 2, we get 8, which is still greater than 1 times 2, which is 2. 4 times 1, which is 4, is still greater than 1 times 1, which is 1. And we get to multiplication by 0. 4 times 0 is 0, 1 times 0 is 0, so this is no longer an inequality. It becomes an equality because we put an equal sign in there. Now if we look at what happens when we multiply by negative numbers. If I multiply 4 times negative 1, I get negative 4, and 1 times negative 1 is negative 1. Well, negative 4 is actually smaller than negative 1. It's further to the left on the number line. So 4 times negative 1 is less than 1 times negative 1. 4 times negative 2 is negative 8, which is less than 1 times negative 2, which is negative 2. And last but not least, 4 times negative 3 is negative 12, which is less than 1 times negative 3, which is negative 3. As you can clearly see here, when you multiply by a positive number, if we look at the question, it says, what happens to the inequality when you multiply each side by a positive number? The inequality symbol doesn't change. Positive number, positive 3, inequality is greater, positive 2, inequality is greater, positive 1, inequality is greater. Okay, so in this particular case, there's no change to the inequality symbol. What happens to the inequality symbol when you multiply each side by 0? Well, when we multiply both sides by 0, my inequality became an equality. So the inequality becomes an equality. And last but not least, what happens to the inequality symbol when you multiply each side by a negative number? Well, when you multiply by a negative number, you'll notice the inequality symbol switched. That's what happened when we multiplied by 4 times negative 1 and 4 times negative 2 and 4 times negative 3. So the inequality symbol is reversed. This leads us to a general statement about inequalities. Okay, and basically that means that if you multiply or divide by a negative number, you must reverse the inequality symbol. Now this only works with multiplying or dividing by a negative number, not if you get a negative answer. Okay, that's very important and it's a good thing to pay attention to. So let's take a look at this next thing here. So here's your multiplication and division properties of equality. If I let A, B, and C be real numbers where C is greater than 0, then if A is greater than B, then A times C is greater than B times C. If A is less than B, then A times C is less than B times C. If C is less than 0, however, which means it's a negative number, if A is greater than B, then A times C is going to be less than B times C. If A is less than B, then A times C is going to be greater than B times C. And the same thing happens with division. Okay, so what does that mean for you? Well, what that means for us is as we are going through our problems, we need to remember to look at things and determine whether or not there are any inequality symbols that we need to reverse. So if we look at problem 1 here, it says z divided by 3 is greater than negative 2. To get z by itself, we need to multiply both sides by 3 because they divided by 3. So we do the opposite. We're going to multiply by 3 over 1, or just 3. These would cancel over here, giving me z. I did not multiply by a negative number. I may have a negative answer here, but I didn't multiply by a negative number, so I do not switch my inequality symbol. So z is greater than negative 6. Okay, and of course we should, whoa, that's a terrible graph. We should graph this. Okay, I'm just going to draw a line. I want to draw a number line. There we go. That's much straighter. Okay, so if I say z is greater than negative 6, I basically can put a negative 6 here and a 0 here, open circle at negative 6 with a line that goes to the right. Okay, and I can check it. It's always a good idea to check these because this will help you figure out whether or not you were supposed to reverse your inequality symbol. If I check this, I need a number that's greater than -6. So let's just choose -4. So if I have z, which is -4/3, is greater than -2. Well, -4/3 is -1 1/3, which is definitely greater than -2, so that works. All right, so that definitely checks. Let's look at number 2 here. We have 3 is less than or equal to -3/5 x. To solve this, I need to multiply by, if you'll notice, they multiplied x by -3/5. So I need to divide by -3/5, which is the same thing as multiplying by the reciprocal. So I'm going to take this and I'm going to multiply it by the reciprocal, which is -5/3. Don't forget the negative sign. Okay, over here on the left-hand side, any whole number can be written as a fraction over 1. So I'm going to multiply this by -5/3. So these 3's will cancel out, and I get -5. Since I multiplied by a negative number, my inequality symbol must switch, is greater than or equal to x. Okay? It's probably better to rewrite this the proper way. Write it with the variable first, x. Notice it's pointing toward the x. It's open toward the -5. So you're just going to rewrite it like that. So now you can graph it. Okay? So if I go to graph it now, draw my number line. Here's 0. Here's -5. Here's +5. It's less than or equal to -5, which means it's a closed circle at -5 and a line that goes to the left. Let's look at a couple more examples. Number 3, -4c is less than 24. Okay, here they multiplied c by -4, so to undo that, I'm going to divide by -4. Okay, divide by one side by -4, I have to divide the other side by -4. I divided by a negative number, so I will flip my inequality symbol. So now I have c. Instead of being less than, now it's greater than. 24 divided by -4 is -6. And again, I need to graph this. So I have -6, 0. So greater than -6 means an open circle at -6 with a line that goes to the right. And I'm going to check this one. I didn't check the last one, but I should check this one because this is a division problem, so it's slightly different. So I need a number that's greater than -6. -2 is greater than 6, so let's check -2. So we have -4 times -2 is supposed to be less than 24. Well, that's 8. 8 is definitely less than 24, so that checks. So it does work. We get to number 4 here. You can either divide by a decimal, or you can clear your decimal. It doesn't really matter. If you don't like decimals and you want to just clear your decimal to begin with, you can do that. Okay, so if I multiplied everything by 10, if I took this entire equation and I multiplied it by 10, I would get 6 is greater than -2n. Okay, so then I'm going to take and say, oh, they took n and multiplied it by -2, so I need to divide by -2. I divided by a negative number. 6 divided by -2 is -3. I must flip my inequality symbol, and then I get my n. If I want to write this so that the variable is first, it's pointing toward the 3, it's open toward the n, so n is greater than -3. Draw my line. -3, 0, 3, greater than, it does not include the negative, so that open circle at -3 with a line that goes to the right. Okay, and again, we can check it. A number that's greater than -3 would be like 0. Let's check 0. So I have 0.6 is greater than 0.2 times 0. Well, 0.6 is definitely greater than 0, so it checks. Number 5 here. We're going to write and solve an inequality. Remember, whenever you write or solve an equation and or an inequality, you have to have a variable. You have to define your variable. So we're going to define our variable after we've read our question. Students in the school band are selling calendars. They earn $4 on each calendar they sell. Their goal is to earn more than $328. Write and solve an inequality to find the fewest number of calendars they can sell and still reach their goal. Okay, so X is going to be the number of calendars I sell because it says we need to find the fewest number of calendars. Okay, so if I go by that, I'm going to let X equal number of calendars. Okay. They earn $4 for each calendar. Their goal is to earn more than $328. So the price of each calendar times the number of calendars has got to be greater than $328 because it says more than. It doesn't say at least, because if it said at least, then we'd have to put an equal to sign, but it says they want more than $328. So the price of each calendar, that's $4. The number of calendars is X because we don't know how many we need to sell, and we need to have that greater than 328. So there's our inequality. We've defined our variable. We've written our inequality. So now to solve this, divide by 4. Divide by 4. X will equal, 4 goes into 32 8 times, 4 goes into 8 twice. So they need to sell at least, okay. So if they have to sell, excuse me, I made an equal sign there instead of a greater than symbol. Okay, they have to sell more than 82 calendars. Okay, so if we're gonna label this, we would have to write this as a sentence. Okay, the fewest number of calendars. We need to find the fewest number of calendars. So the fewest number of calendars would be 83 because they have to sell more than 82. Okay, so they must sell at least 83 calendars. Ah, I didn't spell calendar right. There's an A before the L. Okay, so we've defined our variable, wrote our inequality, and we solved and interpreted our answer because it said find the fewest number. Well, the fewest number would be 83. 83 calendars will give them more than $328. Anything over 83 is bonus for them. So they must sell at the very minimum 83 calendars. Number 6, a student club plans to buy food for a soup kitchen. A case of vegetables costs $10.68. The club can spend at most $50 for this project. What are the possible number of cases the club can buy? Okay. So if I look at this again, normally the question that they're asking you is how you define your variable. So it says, what are the possible number of cases? Okay. So I'm going to look at this and I'm going to go, okay, I'm going to let X equal the number of cases, or N, or P, or Q. It really doesn't matter. Okay, so I know that the number of cases multiplied by the cost of each case cannot exceed $50. Because I only have $50. If it comes to $50.55, I'm going to have to go begging somebody for 55 cents, otherwise I'm going to look rather foolish. So if I know this, okay, so the number of cases, I don't know how many cases I'm going to have. The cost per case is $10.68. So $10.68 times the number of cases has got to be less than or equal to $50. It cannot exceed it. It cannot go more than. At most means they can go up to $50 or less than $50, but they cannot go over $50. That's why we know this is going to be a less than or equal to versus just a less than. Okay, so since they took X and multiplied it by 10.68 for us to solve this, we're going to divide by 10.68. Divide both sides by 10.68. And this is where having your calculator handy would be really helpful for most of you, because most of you probably cannot divide or do not want to divide this big giant fraction. So 50 divided by 10.68, and you're looking at this going, Mrs. Sheline, this is a very long decimal. You're right, it is a very long decimal. We get X is less than 4.68 164794. And depending on how many digits your calculator has, it may not give you that many digits. But I know that I can set, if it's 4.6 cases, I can't buy part of a case. I can't go to the grocery store and say, can I have half of this can of beans, please? Can I have half of this case of Coke? No, you have to buy the thing in full cases. So they can buy 4 cases, but they can't buy over 4 cases. So it says, what are the possible number of cases they can buy? They can buy 1, 2, 3, or 4 cases. Now we don't want to just say they can buy 4 cases or less, because or less means we can go into the negatives, and you can't buy a negative number of cases of vegetables. Hey, I'm going to go to the grocery store and I want to buy -3 cans of chili, please. That means you're going into the grocery store and you're taking cans of chili out of your own kitchen and you're putting them on the grocery store shelves, which they're going to think is really weird. Okay? So you cannot have a negative number. So the number of cases that they can buy is they can buy 1 case, 2 cases, 3 cases, or 4 cases. All right, our closure question for today. When should you reverse the direction of the inequality symbol? Remember, we've talked about that. That was in the beginning of the notes. I've stated it many times. When should you reverse the direction of the inequality symbol? Please answer that question.